Study of gas laws. Here we'll study about Boyle's law, Charles' law, and Kelvin scale. Pressure exerted by gas. Gas exerts pressure in all directions. Molecules collide with each other, also against the wall of the container. Collisions of the molecules cause pressure. Pressure increases with decrease in volume. When volume decreases, the same number of molecules strike the wall more frequently. Collisions of molecules increases. Pressure exerted increases. Effect of temperature on volume of gases. With increase of temperature, the average kinetic energy of the molecules increases. Intermolecular distances also increases. Molecules move away from each other. Volume of gas increases. Boyle's law. Temperature remaining constant, the volume of fixed mass of dry gas is inversely proportional to pressure. Boyle's law. Pressure is inversely proportional to volume at constant temperature for a fixed mass of dry gas. Mathematical expression of Boyle's law. At constant temperature, V is inversely proportional to P, or V equals to K into 1 by P, where V is the volume of the fixed mass of dry gas, P is the pressure of the gas, K is the constant of proportionality. Therefore, PV is equals to K, or constant. At constant temperature, the product of the pressure and volume of fixed mass of dry gas is always constant. Therefore, P1V1 equals to P2V2, where P1 is the initial pressure, P2 is the final pressure, V1 is the initial volume and V2 is the final volume. Charles' law. Pressure remaining constant, volume of fixed mass of dried gas increases or decreases by 1 by 273 of its original volume at 0 degrees Celsius for each 1 degree Celsius rise or fall of temperature. At constant pressure, for a fixed mass of gas, let the volume at 0 degrees Celsius be V0, at 1 degree Celsius be V1, and at 2 degrees Celsius be V2, at T degrees Celsius be Vt. According to Charles' law, for every 1 degree Celsius rise in temperature, volume increases by V0 by 273. Therefore, V1 equals to V0 plus V0 by 273 equals to V0 in common 1 plus 1 by 273. V2 equals to V0 1 plus 1 by 273 plus V0 by 273, that is equals to V0 common to 1 plus 2 by 273. Vt equals to V0 1 plus T by 273 equals to V0 by 273 in common to 273 plus T, that is equals to V0 by 273 multiplied to T. Therefore, from here we can conclude that V by T is always constant. Charles' law. Pressure remaining constant, the volume of fixed mass of dried gas is directly proportional to its absolute temperature. V is directly proportional to T. V equals to Kt. Thus, V by T equals to K, where K is the constant of proportionality. Mathematical expression of Charles' law. V1 by T1 equals to V2 by T2, where V1 is the initial volume, V2 is the final volume, T1 is the initial temperature and T2 is the final temperature. Gas law. P1 V1 T1 pressure volume temperature in Kelvin scale at initial state, while P2 V2 T2 is pressure volume temperature in Kelvin scale at final state. Thus, P1 V1 by T1 equals to P2 V2 by T2. Absolute zero. The lowest possible temperature, that is minus 273 degrees Celsius, where volume of all gases becomes zero. Therefore, the molecular motion of gases ceases, and thus this is the lowest limit of absolute scale. Relation between Celsius scale and Kelvin scale. Minus 273 degrees Celsius is equals to 0 Kelvin. 0 degrees Celsius is equals to 273 Kelvin. Any temperature in Celsius scale is equals to temperature plus 273 Kelvin. Any temperature in Kelvin scale is equals to temperature minus 273 degrees Celsius. Example, minus 10 degrees Celsius equals to minus 10 plus 273, that is equals to 263 Kelvin. 100 Kelvin equals to 100 minus 273, that is equals to minus 173 degrees Celsius. Standard temperature and pressure, STP. To study the properties of gases under similar conditions of temperature and pressure, a standard temperature and pressure has been fixed. Standard temperature is 0 degrees Celsius or 273 Kelvin, while standard pressure is 760 mm of Hg or 1 atmospheric pressure. Now let us consider some numericals. Example 1. Gas initially at STP. At constant pressure, the volume is doubled. At what temperature? At 0 degrees Celsius, let the volume be V1. The pressure is constant and the final volume is doubled, that is V2 equals to 2V1. According to Charles' law, V1 by T1 equals to V2 by T2. Substituting the value here, we get V1 by 273 equals to 2V1 by T2. T2 equals to 2 into 273, that is 546 Kelvin. Turning this Kelvin into degrees Celsius, we get 546 minus 273, that is 273 degrees Celsius. Example 2. At constant temperature, volume is reduced by 40%. What's the final pressure? Let initial volume V1 equals to 100 ml. Thus, final volume V2 is reduced by 40%, that is, it is reduced by 40 ml. Thus, the final volume V2 will be 60 ml. Initial pressure P1. According to Boyle's law, P1 V1 equals to P2 V2. Substituting the values here, we get 100 P1 equals to 60 P2. Therefore, P2 equals to 100 P1 by 60, that is equals to 1.66 P1. Therefore, pressure should increase 1.66 times the initial pressure. Example 3. A fixed mass of a dry gas has a volume of 750 cc at minus 23 degrees Celsius and 800 mm pressure. Calculate the pressure for which its volume will be 720 cc, the temperature being minus 3 degrees Celsius. According to question, the values we get are V1 equals to 750 cc, T1 equals to minus 23 Celsius, that is equals to 250 Kelvin, P1 equals to 800 mm, while V2 equals to 720 cc, T2 equals to minus 3 plus 273, that is 270 Kelvin, and P2 is asked. Using gas equation, we know P1 V1 by T1 equals to P2 V2 by T2. Thus, P2 is P1 V1 T2 by T1 and P2. Substituting the values, the answer for the pressure, we get 900 mm.